Hello and welcome to another episode of A Conversation with Carl. Remember to like, follow, and subscribe for the latest content. Now, this is a conversation I've been looking forward to for a while. I am extremely excited and honored to speak with Harvard astrophysicist and best-selling author, Professor Avi Loeb. He is known for his work in astrophysics and cosmology, particularly regarding the first stars, black holes, and the search for extraterrestrial life. He's the director of the Institute for Theory and Computation, head of the Galileo project, and the author of the bestseller Extraterrestrial. Welcome, Avi Loeb, to the conversation.
Thanks for having me. I look forward to it.
So let's get right into this. In your book, Extraterrestrial, you present a mind-blowing theory that our solar system was likely visited by a piece of advanced alien technology from a distant star. I think this relates to an object Hawaiian astronomers caught a glimpse of. Can you help us better understand this?
Right. So the object was unusual, unlike comets or asteroids that we are used to within the solar system. It didn't look like a comet because there was no gas or dust around it. It didn't shed anything that we could see, even after deep observations with the Spitzer Space Telescope. But at the same time, it was pushed away from the sun by some mysterious force that declined inversely with distance squared from the sun. And the question is, what is the origin of this force pushing it? It's not the rocket effect that you often find when you see cometary evaporation. I mean, a comet is propelled usually by the same process that propels rockets or jet airplanes. I once was on a flight and I had nothing better to do than to calculate how much fuel is needed to give the airplane enough momentum to reach the destination. And it works. Physics works. However, in the case of Oumuamua, this interstellar object, there wasn't any gas or dust shed from it that was observable. And so it became a mystery to me. And in addition to that, the object changed its brightness by a factor of 10 every 8 hours as it was tumbling. And the brightness reflects basically how much sunlight is being reflected or scattered by the object. And a factor of 10 means that the object has a very extreme shape, at least 10 times longer than it is wide, projected on the sky, and the analysis indicated that it's most likely flat. And so combining these factors together, I realized maybe it's a very thin object, like a sail, that is being pushed by reflecting sunlight. And actually, 3 years later, the same telescope in Hawaii discovered another object that was definitely pushed by reflecting sunlight. That was validated. And moreover, it had the spectrum of stainless steel. And then the astronomers didn't write any paper about that. It was given the name SO because they realized that it's actually a rocket booster from a 1966 launch by NASA. So it was clearly technological, not a rock. And we know that because we produced the 2020 SO. The question is, who produced Oumuamua?
Can't we follow it, or we just see it for a second and then it disappears and we don't know where it goes?
So the problem with objects that reflect sunlight is just like the situation you confront when there is a lamppost on the street in a dark night. The amount of light reflected from an object is proportional inversely to distance squared. The farther an object is from the lamppost, the fainter it looks. But then the amount of light that you get if you are sitting close to the lamppost has another factor of 1 over distance squared, because that light that is scattered by the object, also the flux from it declines inversely with distance squared. So altogether, an object gets fainter inversely with distance to the 4th power very quickly, and that's why only when the object is relatively close to Earth we can observe it if it's at the detection threshold. Of course, if the object is very bright to start with, you could see it a little farther. Right now, all of our best telescopes cannot detect an object bigger than our biggest rocket, Starship, 100 meters, roughly the size of a football field. We can't see it beyond 5 times the Earth-Sun separation as a result of reflecting sunlight. Of course, if an object generates its own light, you could see it farther out. I did a calculation about a decade ago that a city like Tokyo would be observable on Pluto with the Hubble Space Telescope because it generates its own light. So we can look for artificial lights, but so far we relied on the reflected sunlight from objects, and that limits our visibility just to objects relatively nearby, close to the lamppost is the sun, of course.
How many objects have we spotted, or how many objects have come into your framework that you've
So
seen?
there are plenty of objects that belong to the solar system that are just rocks, asteroids. They come from the main asteroid belt at a few times the Earth-Sun separation. And these are just rocks that were left over from the formation process of the planets. The way that planets form in a system like the solar system is that at first you have a disk of gas that feeds the star. The sun formed out of material being channeled to it through a disk, just like water going down the drain. And then some material was left over. There was a debris disk, and in that debris disk there was dust that sank to the midplane of the disk, and the dust particles stuck together and created rocks, and the rocks stuck together and eventually created a rocky planet like the Earth. So there are some rocks that are left, just like Lego pieces, the building blocks of planets that are left behind. These are either they're left behind from the formation process, or they are a result of two bodies colliding and basically breaking up. And so we see both populations of rocks, and there are plenty, thousands of them that were monitored over the years. However, what we are talking about in the case of Oumuamua, for example, is an object that arrived from outside the solar system. It's not part of the solar system. And the way we know that is because it's moving too fast. It's moving faster than the escape speed from the solar system. So when an object moves fast enough, it cannot be bound by gravity anymore to the sun. And all the objects that belong to the solar system are defined as such by the fact that they keep going around the sun, like the planets
Yeah, so if it's flat, is it just taking pictures of us? Or is it like, are there people on there, or what? I don't know what you would call them, aliens?
It's roughly the size of a football field, Oumuamua, but we don't know what it is because we didn't get a high-resolution image of it. We don't know if it had a payload, how much mass it carried. I was leading a project to develop a light sail, basically a very thin membrane, a film that is being pushed by reflecting light from a laser beam shining on it. And the idea was to push it close to the speed of light, and that would allow us to reach the nearest star within our lifetime, within decades from now. And the fundamental question is, what is the payload? And we have no clue about that in the case of Oumuamua or all the interstellar objects we've seen since then. There were two additional objects. The most recent is 3I Atlas, discovered on July 1st, 2025, and we're still monitoring it. It just passed last week close to Jupiter, and there are some anomalies about 3I Atlas as well, very different from Oumuamua. I should say that just a few hours ago, the most interesting anomaly that I pointed out in a paper based on results from the Webb telescope is that it has a lot of deuterium. Deuterium is just hydrogen that has an extra neutron. Is a proton and an electron bound together. That's a hydrogen atom. But if you add a neutron, that's a neutral particle, you can add it to the nucleus of the hydrogen and you get deuterium. It's still hydrogen, but with an extra neutron. And it is a very useful element for nuclear fusion. When we do fusion experiments, when we think about fusion reactors that we will build in the future, deuterium and tritium are the best components of the fuel for that. And there is deuterium in salt water in the ocean, and you find it in planets. But 3I Atlas had about 1,000 times more deuterium per hydrogen atom than you find in the solar system, in planets, in the sun, and so forth.
And that wouldn't be on like an asteroid or rocks?
Well, so we look at asteroids from the solar system. We look at comets from the solar system. We've never seen before such a high abundance of deuterium. We see it also not just in water. Water has oxygen and two hydrogens. So one of the hydrogens can be deuterium. And that high abundance that I mentioned, which is one deuterium atom per 100 hydrogen atoms in water, or one deuterium atom per 30 hydrogen atoms in methane, which is CH4. These are much larger than we've seen in the solar system. And the question is, where is it coming from? And the scientific papers that reported about that in recent weeks argue that the high abundance of deuterium could be explained potentially if this object came from a star that has a very little amount of heavy elements. These are called metal poor stars that are very deficient in heavy elements. They are sort of the first generation of stars that existed maybe 10 to 12 billion years ago. That's when they formed. And there is a big problem with that. I did a calculation that shows that there wasn't enough material of heavy elements to account for a population of objects like 3I Atlas so that we would see one of them within the survey period that we conducted. And so we're missing the mark by orders of magnitude. What I'm trying to say is, these are just a few of the anomalies of 3I Atlas. There are also geometric anomalies. It came in the plane of the planets around the sun to within 5 degrees, and that's a very small probability, 1 in 500. So I'm saying there are lots of rare properties that characterize 3I Atlas, but nevertheless, astronomy community is locked on the idea that it must be a comet, as much as they are locked on the idea that Oumuamua was a dark comet, meaning a comet.
But you don't think it was, right?
Well, when you say a dark comet, it's an oxymoron because
Okay.
comet is defined by the cometary tail. And so they say it's a comet, but we can't see the cometary tail. And I'm just saying, like the kid who said the emperor has no clothes. I said this object doesn't have a cometary tail. And the adults in the room keep telling me the emperor has clothes that are just invisible.
If you're looking at the universe's vastness, it seems statistically impossible for humans to be alone, right?
Right.
So basically, critical thinking should at least allow us to conclude that the information we have is inconclusive.
Well,
but there's a lot of skeptics.
Beyond that, I should say,
Okay.
because
yes.
if we both agree, and I think everyone would agree, that if life emerged out of a soup of chemicals on planet Earth through random chemical reactions, and you have maybe 10 billion Earth-Sun analogs in the Milky Way galaxy, that's a reasonable estimate of systems just like the solar system, then it's very likely that you get the same outcome from the same initial conditions. Why should we believe that we are so unique? And I mean, that's just common sense. But the issue is really, if you accept that, that's very reasonable, then the imperative for a scientist is, let's go and search for things like us. Let's go and search for things that we will become in the future. We might endeavor to interstellar space. Maybe someone else did that. It's just common sense to go and search for technological signatures. Within the scientific community, that's considered heresy. That's considered controversial. And beyond that, there are $10 billion allocated to the search for microbes within the Decadal Survey of Astronomy and Astrophysics. That's the document that summarizes the priorities of the astronomy community. More than $10 billion allocated in the latest such survey to the search for microbes using a new space telescope, the Habitable World Observatory, and $0 allocated to the search for technological signatures. And I find that to be just inappropriate, because even though microbes might be far more abundant, it's very difficult to find evidence for them, because their signatures are so subtle. You're looking for molecules that they might produce, but then you have to worry about the same molecules being produced by geological processes. So altogether, I'm saying we should hedge our bets. And that sounds to me like common sense, but common sense is not common in academia.
In your recent book, Interstellar, you write about preparing humanity for what you believe is the inevitable, an extraterrestrial encounter. So where are we on this?
It might well be that, as you started the conversation with, that we are being visited. It's just this idea is so repulsive to this possibility, is so unthinkable to professional astronomers that they are willing to either brush any anomaly under the carpet of traditional thinking or not even think about it, not allow discussion about it in conferences. I'm not just saying that because even the SETI community is banning any discussion about unidentified anomalous phenomena in its conferences. And this toxic environment, basically suppresses any fair assessment of whether there are technological signatures around us. And obviously, if you're not seeking the evidence, you will never find it. So it's by choice that the scientific community decided not to give any priority to that search. And I find it to be inappropriate because the public cares a lot about this question. And there was also discussion within Washington, D.C. recently on the release of any information that either the Pentagon or the intelligence agencies have on anomalous objects and extraterrestrial life and intelligence. And there was a directive by President Trump to the Pentagon and the intelligence agencies to release such information.
Well, I mean, a few weeks ago, President Obama, in an interview, made a joke about it. And next, everybody got very excited about what he knew. And then he had to come back a day later and say he knows nothing.
Well,
You know?
I don't think it was a joke. I do believe that there are objects that the government cannot identify. Now, the question is what's the origin of these objects? They definitely have good enough data for serious people to argue that this is not human made. Okay, so there are objects that either look strange or they move in ways that we cannot explain with human-made technologies. And of course, there might be some phenomena that we didn't fully understand and are terrestrial and have nothing to do with aliens. That's definitely possible. But the government is not a scientific organization. You know, when they see something that doesn't belong to an adversarial nation, they might brush it aside, ignore it, or classify it so that they don't need to discuss it. They don't really, the job definition does not involve what lies outside the solar system. So I think it's really important for them to share that information of whatever they saw with scientists like myself, and I can help them figure it out. Because at the very least, it will clear the table from any concerns about national security. You know, it could be that we are dealing with technologies that adversarial nations possess, and we just don't fully understand them. And just to, we need to be sure that that's not the case. And I'm leading the Galileo project at Harvard University. We built 3 observatories, obtaining our own data because we can just look up. We don't need to wait for the government to tell us what is in the sky. And we don't care about human-made technologies. That these are the things that the government cares about.
You write in your theory, seek and you shall find. That's what you're talking about, looking up, creating the 3 observatories. How are we searching for extraterrestrial life? Where are we looking for it?
Well, so the mainstream of astronomy is aiming to look for molecules that are indicative of life, like oxygen, methane, in the atmospheres of planets around other stars. And these are very difficult to detect, and you need a very big telescope in space. It's called, the plan for that is the Habitable World Observatory. Then you have the SETI community searching for 65 years for radio signals. Frankly, radio technology for communication is a very old technology that we used more prominently a century ago. And who knows whether these signals are propagating at the speed of light? Maybe we're not waiting for them at the right time. It's like waiting for a phone call. So these are the 2 activities that are most prominent within science right now. The Galileo project is trying to do something different. And also there is this new frontier of interstellar objects. These are objects that for the first time over the past decade we discovered. And so there is a chance that one of them might be, technological, like Voyager arriving to us from another civilization. And I went on an expedition to the Pacific Ocean to look after the materials from an interstellar meteor that will appear in a Netflix documentary this year. And so the Galileo project is doing a variety of research studies that relate to that question of whether we're being visited.
I would say just because we need oxygen to survive doesn't mean the aliens need oxygen to survive. We don't know what they need or how they're getting it. We know nothing.
Exactly. So my approach in this is very different from Hollywood script writers who are trying to imagine. The latest is, if you watch the new film that came out, Project Hail Mary, there is some imaginative alien there. But I'm not trying to imagine what the other side is, because we're talking about a blind date of interstellar proposal. I'm just saying, let's look for things that are not local, that are not from Earth. We know what the humans were able to produce so far. We know what nature usually provides us with on Earth. And if we see anything that is very different, an outlier, we should study it more. So my approach is just looking for something different.
Could the aliens have been here for a long time and just being very quiet? Or do you think this is a new thing that they've just started to come here?
One possibility is that, if, when I had my daughters as babies, we used to put monitors in their room. And so when you see a planet like the Earth and you might be worried about a potential threat from a civilization that might emerge on that planet, you put monitors. And I wouldn't be surprised if there are monitors in our near Earth that are just aimed at making sure that we do not become a threat to someone else.
So basically, they're monitoring us right now, you would think.
It's a possibility, and also it might well be that there is some camp, in the outer solar system that we are not aware of. Because, as I said before, we can't see a reflection of sunlight from objects as big as a football field beyond 5 times the Earth-Sun separation. So there could be a lot of things out there that we are not aware of in our relatively backyard.
So, what kind of beings do you theorize exist right now?
Well, I can tell you that there is one selection effect that in civilizations that are less accomplished than we are, they would stay on their planet. But those that manage to arrive to us are probably much more accomplished than we are because they arrive at us before we arrive to their backyard. And so I cannot really imagine what are the technologies they have, because we had just 1 century of modern science and technology. We are still at our infancy. One thing I think is clear, that it's very unlikely that we are at the top of the food chain. The way we think about it, we feel superior relative to microbes, relative to animals that we eat in restaurants. We eat them because we say, "Oh, we are superior to them, we can eat them." And I just hope that if we are visited in the future by biological entities, that they will not put us in their soup.
What are the chances of them being friendly?
Okay, so the way I approach it, I'm an optimist.
Okay.
And my hope is that we can benefit more than we can lose out of this encounter. I was actually interviewed by Natasha Zuvez from News Nation, and she said, "I'm really worried about an encounter. Aren't you losing sleep? What would you think if you knew that after the encounter you will die?" And I said that I'm very much, I would still be interested in meeting them, even if I know that I will not survive after that, because a short life learning about something beyond the Earth that is so fundamental would be far more fulfilling for me than having a dull life and listening to all the news reports on News Nation about the mistakes that humans make throughout our daily news briefings. And it's really dull and depressing for me to just listen to the news on Earth. One reason that I'm hoping for higher intelligence in interstellar space is because I don't find it here on Earth.
How do you think we will communicate with these
Oh, that's a
extraterrestrial
very
beings?
serious challenge. That's the most important challenge, because the way you can ask, how does a baby learn a language? And the way it happens is by shared experiences. When the baby has the same experience with the parents that teach it how to speak, the baby understands what is the word that is assigned to a particular experience, a particular object, a particular interaction, and so forth. And that's how a language is being learned. So we will, in order to develop a common language, we will need to have the same experiences. In other words, we need to be in the same room, in the same environment. And yes, if we do have an extended encounter, then we can start developing a language. But if we just get a signal, it would be really difficult to decode what it means, because their experiences may be very different than ours.
But if we can't communicate with them, they pose a threat to us.
Oh, yeah. And that's so I see the positive side of that, in the
Okay.
sense that, the only way to get a lot of funding for space exploration is for politicians to think that there is a threat to Earth, and that there needs to be a planetary defense initiative where we defend the Earth against alien technology. And that could bring $1 trillion a year, comparable, significant fraction of the military budgets worldwide. There are $2.4 trillion. The US alone had $1 trillion in the defense budget of 2026, and now the Pentagon wants another 200 billion. I'm saying, imagine about $1 trillion a year, just like the Pentagon, the Department of War is getting. invested in space. That's about 100 times more than NASA is able to spend right now. And if we have 100 times more than NASA every year, I believe that it will change completely our priorities, the way we explore space. We might build a space platform that allows humans to travel great distances. But most importantly, we will learn much more about our environment. So I see that as a positive. The fact that we will be worried about a potential threat would mean that we invest a lot of money. Because if we always think that, it's part of science and science should not be funded more than $10 billion a year or something like that, we will not learn much more about our cosmic environment. But if
So
we get
how do you turn this fear, this pessimism into optimism? Because you said you're an optimist. How do
yes,
you convince the pessimists who are like they're coming to put us in their soup?
no, I say that's great. That's what you think. Let's invest $1 trillion a year in defending the Earth. And once we do that, it will be irreversible. If the optimistic approach that I believe in is the reality, we would realize that we're not being threatened. But at the same time, we invested so much money in space exploration that humanity will become an interstellar species, because right now we are just limited to Earth. And frankly, I'm not excited about going to Mars, I should say. It's a desert. It's not a place that I would like to go to. It's very dangerous. Elon Musk doesn't speak much about the health hazards there. And so I would much rather build a space platform that provides humans with everything they need. Just like, we moved from the jungles of Africa to high rises in cities. And it took us hundreds of thousands of years. And I think the transition from high rises in cities to space is definitely easier and could just mean that we need to invest $1 trillion a year in space. And of course, the only way that it could happen, realistically speaking, is if we believe that there might be a threat. So after we discover alien technology somewhere in our solar system, I think this will get a high priority.
And then how does AI play in the search for extraterrestrial life?
Oh,
Since
it's
everyone's
very
talking.
well. First of all, in our search, it allows us to analyze large data sets and notice patterns that the human brain does not necessarily notice. But when you go on an interstellar trip, the duration of the journey is very long, and it's very likely that whoever engaged in that used the AI, because this way you can make the system be autonomous, that it can make its own decisions, and you don't rely on biological bodies that are very vulnerable. So I would guess if we ever encounter a visitor, that it would be equipped with AI, and even beyond that, that's what we can imagine now, because it's the emerging technology that we're starting to use. By the way, we haven't used it in space as of yet. And we just had the helicopter parenting of robots on Mars, for example, allow our systems, the probes that we send, to be autonomous. So I hope that the next step for us would be to employ AI in space.
And as we start to wrap up here, is there anything I haven't asked you that I should have asked you?
Oh, there are lots of things. I mean, we can speak for hours or days. But I would say, let's be optimistic that we will learn something important here. That the next Copernican revolution would be that we are not at the intellectual center of the universe. And I think we need this sense of modesty, humility, in order to get better. Because right now we are really, if you look at the news every day, we are engaged in conflicts all the time. If someone knocks on the front door of your home and you realize your family member are engaged in some loud argument, as soon as you tell them that someone is knocking on the door, they would quiet down. And that's my hope, that if we do have a visitor, then we will all feel as members of the same family, the human species here on Earth. So it will bring us to a better place.
Iran, America, and Israel all become friends.
Well, it's not that they become friends. It's just that they recognize a potential threat from a bigger, more pressing risk.
Yes.
So yeah, so it will change priorities. As soon as the visitor will go away, then of course they might go back to arguing with each other. But
You go back because that's what humans do.
yeah.
Professor Avi Loeb, thank you so much for joining me today. The book is Extraterrestrial. Your most recent book is Interstellar. And thank you out there for listening. And if you have comments, as always, put them in the section below. And until next time, everyone, be safe.